Alex Kennis here, and welcome to question and answer number 2 for last month, whatever last month was. This is where I grab questions that were asked of me either on YouTube comments, on my blog, through email, message, or other places, and I grab the ones that I think will be most useful for the community to expound on a little bit in a public setting, and then give those answers to you guys. So this was my second full month of doing the video format, and it's been turning out pretty nice. That whole picture's worth 1,000 words thing really seems to help out, because I always had trouble with my blogs where I'd run into like 4,000 word entries and I'm like, nobody's going to read that far. And then they're going to ask me questions that I already covered in the material because it was just a wall of text. But anyway, thanks for the support in this. I have some more Patreon subscribers and some more folks that gave one-time contributions. So thank you to all of you. I'll mention my subscribers' names right now. As always, I'm going to keep last names out of here and paranoid about internet privacy. And anybody who gave one-time contributions through PayPal, I'm not going to mention your name here because you may have tried to want to, keep it on the down low or something. But let me know if you want to be mentioned and I'll mention you in the next Q&A. So thank you, McEwen. Thank you, Karsten. Thank you, Aaron. Thank you, Pauline. Thank you, Brothgar. And thank you, Jorg. Karsten also bought me this nifty AN 8008 multimeter because he saw me struggling with the one that I have in a couple videos. So thanks again for that. It's going to come in very handy. And let me talk about what's coming up. Then I'll answer some questions. Then I'll close it down with an outro. So the videos have been a little bit thin this week, not because I haven't been working on stuff, but because I've been working on so much freaking stuff. I have about 4 or 5 major projects I need to do. And I also have like 3 projects that I've already filmed from beginning to end that I'm going to be putting out in installments that I need to edit those videos and post them. I'm also waiting for parts for a few of those series because they're coming from various distributors around the world and sometimes it takes like 6 weeks for them to get here. So the stepper motor torque comparison is going to be coming up. The conclusion of the RAM series is going to be coming up. And the beginning of talking about 32-bit 3D printing. Along with that, I'll have to go into a little bit about embedded microcontroller theory and software, that type of thing, how you interface with the hardware. So those segments will be labeled TNTM, Talk Nerdy to Me, and put in a separate playlist because the general user that's just looking for basic information would be like, whoa, what is this? I've spent the last 5 days straight writing embedded microcontroller code and trying out a couple different development environments, none of which I really like. But progress is being made and the videos will start flowing soon. So on to the questions. David Engine says, a decently built RAMPS 1.4, where does one find that? And Carson suggests static boards. The problem with saying a decently built board is like a lot of them are decently built. The problem is that either they cheap out on the board, they cheap out on the parts, or they make mistakes. But it's okay if they cheap out on the parts as long as you know your parameters. For instance, look at my MOSFET video to see the math about what kind of a heated bed your MOSFETs can take. And, the output connectors on the RAMs are supposed to be rated for 15 amps. A lot of times on these boards are rated for 10, which is obviously not enough, but it's only enough if you're running a 15 amp circuit on the output. So unfortunately, a lot of the problems these people have online, which I tried to show in the RAMPS series, is that they'll post a picture of their melted RAMPS board and then just have everybody commiserate with them or whatever. And then it ends up they plugged a board into that, or they plugged a heated bed into that wants to pull like 16, 17 amps. And then they didn't even bother to check the ratings of the connectors, which were rated at, 10 amps or 12 amps or 15 amps. So the correct answer is, why did you plug a 16 amp bed into a 12 amp connector? But that's the difference between like a closed ecosystem where everything's compatible and the RAMPS modular thing where kind of sky is the limit. If you don't know what you're looking at and you're not careful, you can kind of hurt yourself or hurt your board. So as you saw in my part 1 of the RAMPS series where I was, comparing as many of the boards as I could grab that quickly, they all had strong suits and weak points. For example, like the ZYL Tech board was really well made. The pins were gold plated, had a nice thick solder mask. The through holes were plated, but they got either a batch of really bad below spec MOSFETs or counterfeit MOSFETs. And they were way out of specifications, even for, worst case scenario. So I actually, I had one of those boards and I pulled it apart and destroyed it for the testing. And I actually bought another one because even though the MOSFETs are utter garbage, I know I can pull those off and the rest of the board's going to be pretty good. Another example is like The ramps 1.5 is pretty good and ready to go out of the box, but they iterated on the open source GPL designs and then didn't post those updates online, so it's really confusing to the open source, hobbyists, that you really need to be able to look at those schematics, look at the diagrams, look at the pinout and the solder mask, and see where all the different bits and bobs are supposed to go and what's hooked up to what, because we don't know what you changed. We don't know what the voltage ratings of your little board capacitors with no markings are. We have to know that if we're going to be able to safely use these things. So for general use, something like that's okay, but if you're getting tricksy, then you're missing some important information. And then there's like the Kia Studio and the Robotal boards that were pretty nice overall, except for the fact that there was an error in the PC board when they etched them, and all of the little MS jumpers are bridged, so you would have to go in and scratch those out if you wanted to be able to use the jumpers or use Trinamic chips. Second question is from Jason Clark. The RipRap Champion stuff in particular I am wondering about. Looks like their Amazon storefront is empty. Yes, RipRap Champion, the two owners had a split. They started different stores. What was RipRap Champion is now called Gulf Coast Robotics, and they're selling on Amazon again under that name. You can also go to like gulfcoastrobotics.com or whatever. Just do a Google search, and that's the same guys. And if none of you know who they are, they're the guys that had the well-made E3D all-metal clones for really cheap, and other various cheap parts. ZDoc asks, I wonder if you could also do a torque test on the TMC 2130. Very nice video. Thank you very much. I will be doing, as I've mentioned before, torque tests on a bunch of different step sticks. I'm waiting for some parts to come in. I have to decide what to do with the software, whether I want to drive it from Marlin or not. And unfortunately, there's a problem with the stepper drivers and SPI steppers in the bug fix version of Marlin right now. I'll talk about that a little bit more later. But I was going to use that for this test, and it looks like I can't do that reliably, so I may have to go outside of Marlin and ramps and just hook the steppers up to a breadboard and write a little program to do that manually. We'll see. I'm still trying to decide on that. That's why I haven't gotten to it yet. Cthulhu Piss asks about blade fuses on ramps. Yeah, there's a big discussion if you look at the what is that, ramps part 4, the polyfuse part, about using automotive blade fuses on the ramps board, and like how do you do the holders. I haven't been able to find holders that plug right into the sockets on the board, unfortunately, so you have to get tricksy with it or use like an off-board type of a setup. He posted a link to a Thingiverse where somebody 3D printed a socket and then used solder strips, the little strips that you use to build battery packs with a tiny little arc welder thing. I have one around here somewhere buried on a box of nonsense. And he just kind of bent those into a fuse holder shape, stuffed them into a 3D printed thing, and then soldered some wire to it and put that through the holes. That type of a thing can work, and I put the warnings underneath the video, but I'll hit on the basics right here. The reason I don't do things like that is I don't like to mess around with safety mechanisms, like Mickey Mousing a solution together. So I had suggested using actual fuse box terminals that are meant for those blade fuses, and then just solder those to a piece of solid core and solder and crimp. Well, crimp, then solder, and then solder those to the board, because they're going to be good. They're usually gold plated, and if they come from a decent manufacturer like Little Fuse or something, that they work. You can look at the ratings, you can look at the contact resistance on the data sheet. Now if you're going to use those strips, it is possible. It looks like the guy who posted those files has been using for like a year, but he doesn't post all of the relevant information. So that's the kind of problems that you can run into with this sort of like open source stuff. We would need to know the conductivity of the material. We need to know what the thickness is and the width. He gives the width. And then we would have to calculate, depending on the resistivity, how much current we can pull through that without it heating up, and then we end up with the same problem you have with the green connectors, because that's exactly the problem you have with the green connectors. That and contact resistance with people putting them in wrong or not capping their ends and that type of thing. Now, obviously, you have a lot of contact resistance if you're just using a mechanical slot. Unlike these are a step down from the green connectors in that you're not even bolting them in there. You're just slipping it in. So when you're taking that little strip and bending it into the M shape and then stuffing a fuse in the middle, it's not going to be perfectly flat. So you're going to have conduction in some places and not others, and that's going to be variable in your contact resistance. If you do a good job with it, you'll probably be okay. If the strips are solid nickel and fairly thick, you should be okay. Just eyeballing what he said in the post, my brain went, oh, they're 3 millimeters wide. He's putting this on a circuit that was intended for up to 11 amps, and people use it to run up to 15 amps. Well, 3 millimeters wide, if it's, I think those strips, like the skinny ones, start at like 0.1 millimeters, which is a little less than 4 mils, which is a little more than 2-ounce copper, I think. Yeah, it's a little more than 2-ounce copper. So if we were talking about a PCB trace and 2-ounce copper at 3 millimeters wide, that's not enough for 15 amps. That's not enough for 10 amps. It's enough for 10 amps. You would need either thicker copper or a wider trace. So if you find those, at least, like if you're going, you can go wider than 3 millimeters, I guess, or you can go thicker. Make sure it's like at least 0.15 millimeters, preferably more. The thicker the better. He also just soldered the tabs directly to a piece of solid core wire, which is a thing you could do, but if they're super thin and there's a lot of contact resistance and they heat up, it's going to become desoldered, and then you're going to have live voltage flopping around, making intermittent contact with your fuse connection. So those are all just things to think about. Not trying to scare anybody, I'm just bringing the design issues into this. Daniel O'Connor asks, one thing I've noticed about RAMPS 1.5 is there's no PS on connection next to the reset button like on a RAMPS 1.4. Any chance you stumbled across this in your research? Yes, they moved that header up to the top of the board near the extruder sockets. It's on the top silk screen near the header row all the way up on the upper left. You can just find it there. Donnie Harrison says, pause this John, you say. You must be from the East Coast, LOL. Yes, I live in Center City, Philadelphia, home of the Liberty Bell, psychotic sports fans, and the cheesesteak. Baji Koi asks a bunch of things in a long question. Let me sum this up. You really know your stuff. I agree with the changes will be great improvements. There's a rearm for ramps that supposedly gets you a 32-bit Duo compatible system with a standard board. It costs us $45, and I think it's the cheapest solution as matter hackers if they get them in stock. That's without playing into Ramps FD or RAD's territory, blah, blah, blah. I'll be covering a lot of those 32-bit board options in the future. To give you a taster, the cheapest way to do it is just to hack a Ramps board to fit on a Duo, but Duo is technically discontinued. Now, I think they may have brought it back. There's a story behind all that I won't get into right here because it's too long. But it got bumped into the retired stuff. There was outcry. It got pushed back again. They made some what I consider to be bonehead design decisions with the Duo, and it didn't catch on like they hoped it would. Everybody was waiting in anticipation for it to come out, and it's thrown a huge hurdle in the path of the 3D printing world, because we were all just kind of hoping that we could take all of our mega plug-in shields and whatever and just stick them onto a Duo, and that doesn't work without modification. So yeah, you can modify a ramps board to fit on a Duo and have a 3D system that's fully supported in Marlin 2.0 Bugsfix branch, but the mods are a little sketchy. You have to cut solder traces and run jumpers outside of the board depending on like what features you want. It's not hard, but since the pins on the Duo are not 5-pin compliant and the Duo sits right on top or right underneath like a ramps board or something like that, it's getting something in between, like where it's coming from and where it's going, is rather difficult unless you run something externally. They also don't have an EEPROM, so you can rig one up or put one as software on an SD card. But the 5-bolt compliance is a big deal because you can't just take your ramp stuff, plug it into a Duo, and have at it, because you will fry your Duo and your external parts won't work. So that's why I don't really like the Atmel 32-bit chips. The STM32s, they're more legacy compliant. They also have some nicer features, and they're exponentially cheaper. So I'm going to be working with those a little bit in the future. We'll see how things work out. But there are already 3D printer board designs based on those chips out there. They just use custom firmware. Let me see what else. Oh, Ramps FD and RADs. Yeah, Ramps FD was Bob C and another guy. Sorry, other guy, I forget your name. They were working on those boards a little while back. The problem was they did their first like prototype version and told everyone like, this isn't safe, we're just testing this out, we need to hammer it out. And they put the design files out in public. Somebody stuck them up on the RipRap wiki, like Chinese mass manufacturing found it and just ran with it and made a whole bunch. So you can't buy a safe Ramps FD board right now. They're dangerous. Don't get them. Ramps, the improved version that won't burn your face off, is not available anywhere. You can't get it. And the original guys, they're not, as far as I know, they're not working on it anymore, and it's just been picked up by other dudes. It's a decent board. There wasn't some consensus on a few issues, and I think they added some unnecessary features. They should have been called like Ramps for Duo Plus or something like that, because it's not a new Ramps. It's a more Ramps, more stuff. The Ramps is just a basic shield that fits in the form factor of the actual Mega or Duo. This is a, what I call a hangover breakout board. And that's the same with Rads. Rads is safe and it's available, but it's expensive. It's not a GPL open source design. It's a CCNC design, Creative Commons non-commercial. So you're not going to see those cheap. So if you're waiting for a Rads to get cheap or looking for it cheap, stop looking. You're not going to find it cheaper anywhere. You're going to be paying $80 for it or whatever they're charging, because you're not allowed to make them and sell them yourself. And then there are a lot of other boards, and I'll cover that in a video. Cost is by far the biggest limitation. 32-bit computing. Really hope more Ramps compatible boards go on the market to lower the cost, etc., etc., etc. It'd be awesome to flip-flop between 8-bit and 32 by swapping a single piece. Yeah, I agree, and I'm helping some people to try to make that happen, or some people are helping me to try to make that happen. We're going to try to make that happen. Davis Pruitt, what Ramps or Ramps type board would you recommend? That calls back to the other Ramps question that I answered. It really depends on your needs. So just like determining anything, see what your targets are, what your operating voltage is, what you expect to be able to do with it, whether you're running a heated bed, all that stuff. And then you have to make your decisions based on what's out there. So even boards with bad MOSFETs or subpar MOSFETs, at 12 volts, they will be dangerous. At 24 volts, they're probably okay, because the whole Ohm's law thing. More voltage, less current, happier MOSFETs. Some boards also come with either slightly or greatly updated MOSFETs, and then there's the surface mount versions. So yeah. Here's a question from my blog. Sorry, this is a math question. How are the Butterworth polynomial Q values created? What's the formula, and do you have C code for this? What does the S refer to? Is this the sampling frequency? I posted a Butterworth filter even order coefficient calculator because I had, what was I doing at the time? I was cascading biquads and I needed double precision numbers because using even singles was not stable enough. Doubles worked fine, but I hard-coded the normalized polynomials into the function because there's no reason you would ever have to calculate those again. They're always going to be the same. And I was only interested in even order, like 2, 4, 6, 8. What polynomials do we appreciate? There is no code. At least I didn't find any code. It's not something that I think many people have bothered to write, since you only have to calculate them once. But the math is well known. If you go to like DSP related or even Wikipedia or something like that, they have the integrals there. They have the entire equation. I just did them all by hand since I knew I'd only have to do them once and never again. And I didn't do the even order because the equation's slightly different, and it was really just kind of splitting hairs to go that fine on the divisions. Yeah, so hand math with a calculator. You can also use Wolfram Alpha or any other like integral solver. You can use Google search to do calculus if you want. You just have to put it in a form that it'll accept. And the S that you see in those calculations unfortunately does not apply to sample rate. Sample rate doesn't come into effect until the next part of, if you're trying to generate coefficients, it doesn't come into play until the next part, and even then it's going to be divided by your frequency target, your cutoff, because we're plugging it into normalized coefficients, so agnostic as far as that's concerned. The S is actually it's a complex variable because we have time domain and frequency domain, and we're trying to represent where the poles sit. If you know about the poles with a filter, they're going to be evenly spaced around the left side of the circle, so it actually represents two variables. One is your the one that you're probably not thinking about is the Laplace transform. I'd be of more help if I could. I'm a terrible math teacher because I'm not a mathematician, and I'm certainly no expert in that field. If there's an equation is the only thing between me and a result that I want to have, I'll just bash my head against it until I figure it out. Anyway, Jacob D wants problems debugging his SPI TMC 2130s. I don't know, Jacob, if you're using the bug fix branch of Marlin, but both the 11X bug fix and a 2.0 bugs fix are having some problems with the stepper drivers. They think they have it nailed down to like the planner, but they're not sure. That was one of the things I tested a few other days ago. The great and powerful Thinky Head over there on the Marlin firmware forum had posted a couple different versions of the bug fix to test, and I still had the weird problems in all of them. Mostly it's related to this might help you if you're running these problems. Mostly it's related to the TMC 2130s. So it's showed up in firmware for printers that draw from the bug fix branch, like Prusa and whatnot. And mostly it's a problem when you're running at low speeds, low jerk, low acceleration values. So the way that I've kind of gotten around it on the printer I have the bug fix branch installed on is print faster than I normally would. I know that's not a great answer, but it seems to make the problems go away. Also, it seems to have problems with curvy objects. So if you have a square object, you could print it at normal speeds fine, but something with like straight lines and curves seems to make things go wacky. So it might not be your SPI problem, it might not be the Trinamic problem, it may be a firmware problem, and it's actively being worked on. Also, SPI in general, I had another question. Let me see who asked that. Jacob S. Sokolov. He was having problems with the SPI controlled chips and printing off an SD card reader. The problem is there's so many variables with the SPI bus that it's hard to like give an answer that'll work for everybody. Again, this is one of the problems when you're not talking about a closed ecosystem, when like sky's the limit and you don't know, what kind of SD card reader you're going to get and how well it behaves. You just can't give one answer that fits every situation. So it's possible in an SPI chain, since they all kind of run off of each other. It's possible that if, for example, your SD card is at the end of your SPI chain and your reader is a particular misbehaving naughty little reader, it may have to be buffered from the rest of the chain for them to be able to behave properly. So one thing you could try is just disconnecting anything that's not your Trinamic drivers from your SPI bus and see if it behaves. If it does, then it's probably one of the devices on your chain that's either has sketchy wiring or power, is poorly built, or just needs to have a buffer. And some of the the display ports with the integrated SPI card readers, so some of them are buffered, some of them aren't. I think the standard that the 2004 20 character by 4 layer RipRap Champion LCDs that you can get real cheap, I don't think they're buffered. So I've had problems with those, but others of similar design I didn't have any problem at all with. So check that out. If you can find the schematics for your particular SD card reader, see if it's buffered. If it's not, try grabbing another one and hooking it up temporarily with like DuPont jumpers. I ordered a whole ton of different SD card readers for a project I'm doing. This is for the smaller ones, but these were 71 cents a piece, I think. I had to buy them in lots of 5, but it was like a couple bucks, so it was no big deal. And then you can also get them for the bigger cards, which I haven't even opened yet. And then DuPont jumpers cost like nothing. And you can always just wire up your display separately, or just grab a $5 LCD somewhere, or like one of these little itty-bitty 1-inch OLED guys and hook that up temporarily. Alrighty. Claus16821 asks a bunch of questions. Let me see which of these I can answer succinctly and would be useful. He asks first off about ramps at 36 volts. Now, if you're talking about 36 volts, you just have to trace the signal chain down from your input and make sure everything is compatible. Now, all these little round silver guys, these are your filter capacitors. They're on the power pins of your steppers and then the thermistor inputs at the bottom here. Those all have to be rated above whatever your voltage is plus a safety margin. So the solder tabs are on the side. You can replace these by hand. I've done it. It's a pain in the butt, especially when you have headers in the way. But it's best to just find a board that has these rated to what they want. I've squealed for a long time that I wish I could find a ramps board with capacitors rated at like 50 volts or 63 volts or something like that. Because even the old Pololu 4988 steppers will take up to like 36 volts. But the ramps cards were originally designed around 12 volts and using a computer ATX supply to power them. Because of demand, some manufacturers, most even, this was a $3.20 board and they've done the upgrades. Most of them are compatible with 24 volts now. So yeah, what you want to look for is make sure the capacitors are cool. Make sure your fusing or polyfusing is cool. These two polyfuses are rated at 30, again on a $3.20 whatever cent board, so that's fine. Make sure your MOSFETs will be able to handle whatever voltages you're putting on them. That'll be in the data sheet. These have been upgraded to 3205s. Your connectors are safe to like 250 volts, that's fine. So the only other things you have to remember are these are your LEDs right here. Your LEDs are attached to the limiting resistors right there. That limits the current to them so that you don't A, blow out your LEDs, and B, suck too much current through your mega and fry that pin. So you have to just plug that into like an LED calculator, or you can use Ohm's law calculator. Take the voltage drop of your LED, subtract that from your operating voltage. Usually these are good for like 10 or 20 milliamps. You'll have to check the mega pins that they're hooked up to if they're indicators and hooked up to those. I don't remember off the top of my head, and make sure that you can pull at least 20 milliamps from them. Or if you really wanted to go nuts, you can replace the little surface mount resistors there with something better or higher volt value. Or replace the LEDs on the board with something with a higher voltage drop. I don't remember what color these are, probably like red and yellow, but if you replace them with like blue, violet, or white, those have a higher voltage drop and it'll buy you a couple volts of headroom, but you're better off raising the value of the current limiting resistors. Powering stepper drivers externally. Yes, you can do that. I think I answered this in a question. I answered a ton of questions the last few days, so I forget what I did and did not reply to. But that would be, you could take the pins on your step sticks, put them on upside down, and instead of running voltage from your ramps board, run it from an external supply. Nothing wrong with that at all. The one problem is these pins, the voltage pins should be bypassed like right at the pin. Those capacitors are mounted on the board, so just make sure you add some filtering right there that's going to run down to your ground or your ground reference. Other question, using risers for drivers. Yes, I use these risers for drivers. As you've seen, they come very long because they're meant to be trimmed down. So if you just stick them in, they stick out like that. So you want them to sit as flush as possible and just trim those off to the height that you need. There's no problem using that because it would be just like, you know, this is a shield, so it would be like running another expansion shield on top of a shield. It's how these things work. But again, you are moving your chips a little bit further away from that filter pin or from that filter capacitor, so just be aware of that. Ramps PCB. Oh yeah, ramps. I had mentioned that some of the boards have the MS jumpers bridge. That's these little jumpers that are underneath the step sticks that you use to set the micro stepping on, you know, non-trinamic drivers or trinamic drivers in legacy mode. Some of the boards, those are bridged, so what you have to do is pull the plastic headers off with a pair of pliers. You'll have to wiggle it off, and then I don't have one around here. I take a Allen wrench and just scratch between them because the traces are on top and they're very thin. And then you can take a flashlight and just shine it underneath to see through the PC board to see if you got through the traces. Now, if you're also looking at that, you'll see that there are traces very close to those jumpers that you don't want to scratch through. So be careful. And you don't have to scratch them with an Allen wrench. You could scratch them with a scalpel or a knife or whatever you have around. Is it economically feasible to build a DIY ramps from scratch? People did that back in the day, and you can still get the boards from various places, either with the surface mount parts already on it or not. The problem is you can't really specify, and it tends to be more expensive. The reason is these ramps from China, you know, this was, like I said, $3 and something. If I were to order, say, one of these capacitors, I looked it up on DigiKey, it's like 85 cents a piece, times 9, and then you have all the other giblets on here. But if you were to buy these like a board house would in quantities of, say, 50,000, it's going to be maybe like 5 or 10 cents at the most. But that applies with everything: the jumpers, the pins, the connector stuff, the MOSFETs. So the fact of the matter is, like, unless you stumble upon all of those parts, you're going to be paying 10 times more, 20 times more for everything you put on that board than a board house is going to. And they also they use pick and place to put all the surface mount stuff. That's all automated. And they have stencils to put the solder paste on there if that's the way that they're doing it. So if you were going to do surface mount soldering at home, the easiest way to do it is with a stencil. It's like it's just a metal stencil of the top etch, and it has holes in it where all of the pads are that you're going to be soldering to, and then you just squeegee, like silk screening. If you've ever silk screened before, maybe that doesn't help. You're just going to like squeegee the solder paste on there. You pull the mask off, and then you would take tweezers and put all the surface mount parts down, and then just bake it. It's not that hard. The problem is it takes a little bit of a touch to know how much paste to put in there, and not to, you know, a steady hand to not smear it around and get like bridges. And you need, of course, the solder mask, or the stencil mask for it, which you would have to have made, I guess, unless somebody has a ramp stencil mask lying around, or they want to laser cut you one or something. So yeah, you could do it, but it's expensive. That was the option I was going to take with some of my personal printers, but I'm doing okay with just modifying regular ramps boards and making sure they're safe. And this will be the final question, and this was from Claus as well. He was asking about using an encoder to correct movements on the axes of 3D printers. When you take a stepper and you stick an encoder on it and close the loop with corrective feedback, that's called a hybrid servo, and I most definitely think that's a way that we should be going. It's a project I plan to mess around with in the future. It's just it's way down on the list, and that's a more like esoteric experimental thing. I want to cover first, before I get to that stuff, I want to kind of cover the, you know, like basics of safety issues, and, you know, how to know what parts are going to suck and things like that. But I will get to it. And there are projects that are available already, like Mechaduino and the other one, that have like an encoder, and I think it's built off an Arduino Zero. And there's also the driver that's on the chip, and it mounts to the back of your stepper. But you need a particular stepper that you can see through the back. Like this one, where you can see the shaft through the back, so you can put a magnet on it that's polarized this way, north and south, and then there's like a Hall encoder on the back. And that resolution is good enough for a 3D printer. But their kits are like $65 if you get it like with the stepper. If you have a stepper that works, it's like $50 per axis. So it's pretty expensive. You can also get ready-made industrial solutions that are hybrid servo systems and have all of the software and firmware and hardware and everything's an integrated system, and you can plug it into your computer and tweak all the parameters, but they're a couple $100 an axis. Trinamic even makes one. They make a bunch. I forget what that ecosystem is called, but yeah, they definitely have it, and it's definitely expensive. And I mentioned in my reply that it's very possible to do it yourself. The reason that I haven't just like toss one together, that's not true. I have tossed one together, but not for a 3D printer. It's for that magnetic coil winder that I built back there. But as far as like you know, the 3D printing stuff, like I wrote all of that firmware from scratch, and I could just toss whatever I wanted wherever I wanted. But you have to be able to tweak it in for each system and deal with like overshoot, undershoot, hysteresis, and all that nonsense, talking about like the movement and the bang, that kind of deal. And if you've ever worked with like industrial servos like I have, those are all well-known issues and are solved through software. So anyway, that takes time. I know that takes time, so that's why I haven't dug into that before I get to some of the more important stuff. Or I should say safety related and basics stuff. But when I do it, I'll probably be using like a cheap MCU breakout board like this. These are like $175, plenty of room for enough firmware to run a servo. I'd have to decide whether I want to link it up with, you know, Marlin, Rapetti or whatever, or just have it run on its own and not worry about the actual 3D printer's firmware at all. And these are cheap enough. You could do like one per axis with an encoder, and probably an encoder and like an optical disc or something like that, and it'll be under, you know, I don't know, $5-10 an axis, depending on how cheap you can get the encoder chip for. So anyway, I hope some of that wasn't too boring, and I'll repeat, I have the final wrap-up of the RAM series coming up. I have more of the Cigar Box Ukulele stuff coming up for you instrument builders. Definitely some MCU programming stuff. I might give some intros into like 32-bit programming on the Arduino and whatnot. Definitely getting into the basics of 32-bit printing, where we stand right now, what you can and can't do, what's ready, what isn't, and what boards are available for you at the moment. And then branching off that into some like experimental, like woo-woo land. Because of Patreon support, I was able to go on like a Banggood and AliExpress, eBay, Amazon buying spree of little tiny widget boards, like all these crazy little things. And I plan to put out some videos on like how to add Wi-Fi to a ramps for like $2 and adding another SD card reader, like that kind of stuff. And those are just like, you know, fill in the cracks kind of little projects that I'll toss in from here and there. But it's all possible because of my Patreon supporters. So thanks a lot. And if you're interested in supporting this channel and this type of like particularly nerdy stuff, support links are down below. You can do one time through PayPal. You can do Patreon for a monthly thing. You could also just go down to the Bandcamp links and grab a digital download of one of my band CDs, or buy a copy as a gift for a friend if you're a weirdo that's not into death metal. And occasionally I have affiliate links at the bottom, and you know how that works. They kick me back a small percentage of anything you buy. And I'll try to post those down with links to, like, if I review one of these little gizmos, I'll be like, you can get it here, and they'll give me a penny if you buy one. Whatever. So thanks a lot. I'll get the next video up as soon as I can, and until then, get out there and make something awesome.